For the following, state the number of valence electrons and write the electron dot symbol. Valence electrons are the outermost electrons for an element. Electrons in the last layer, energy level. Those are the ones that are going to be reacting, giving or taking to form different things. So there's a little trick, especially with the main group elements. We know that main group elements are A's. We have 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. These help tell us how many outermost electrons there are in those groups. So the electrons help us determine the physical and chemical properties of different elements located in the same group. So for example, if you look at lithium and sodium, they're both in group 1. So they both have one valence electron. However, lithium has 3 electrons neutrally and sodium has 11. So lithium has 1 valence electron and 2 core electrons. So the other electrons are in the layers more closer towards the nucleus. Sodium has 1 valence electron and 10 core electrons. Where these core electrons are then placed is through what we like to say the electron configuration, where you can figure out which orbitals and how many electrons are in the following. So if we look at the following right here, magnesium, which is right over period 3, group 2A. Since I'm in group 2A, I have 2 valence electrons. Write the electron dot symbol. The electron dot symbol just shows us another version of how the electrons are in the last layer and how they may react. So I would write Mg and then just the valence electrons around my symbol. You imagine that there's a little square around your symbol, and each can take up to 2 electrons. Each line represents an orbital. Your valence, since you're talking about the outermost, you would then say magnesium has 2 valence electrons. You always place an electron in each first before you pair. So, looking at the next one, oxygen, but 2 minus. 2 minus means gained 2 electrons. So if we just look at oxygen by itself, which is right here, it's in group 6A, so it has 6 valence electrons. Therefore, oxygen 2 minus gained 2, so it has 8 valence electrons. So the Lewis dot or electron dot symbol would then look like this. For regular oxygen, I place 1 electron in each side of the square, each orbital. 1, 2, 3, 4. Now I pair 5, 6. You either go clockwise in order or counterclockwise, but you always place 1 in each before you pair. Then if we look for oxygen 2 minus, you would say oxygen 1, 2, 3, 4, 5, 6, 7, 8. Now, because this is a charge, you have to put brackets around it and indicate that there's a 2 minus. If you didn't write the brackets in the 2 minus, I would look at this and say oxygen is in group 6 and only has 6 valence electrons. Where did the other 2 electrons come from? So this one represents your neutral oxygen. And this is the ion, the anion, since it's a negative, of oxygen. Now looking at chlorine, so same idea. Chlorine is in group 7. So regular chlorine has 7 valence electrons. Chlorine minus has therefore gained 1 and has 8 valence electrons. If I then want to show the dot symbol for chlorine, I have Cl, 1, 2, 3, 4, 5, 6, 7. Neutral chlorine. Then, with the ion, I would write chlorine 1, 2, 3, 4, 5, 6, 7, 8 in brackets with the -1 charge. And that would be the electron dot symbol for anion of chlorine. So for the main group elements, you look at your outermost electrons. Your outermost electrons will tell you how many you would place in the electron dot symbol. You cannot figure out the outermost electrons for your transition or your intertransition metals just by looking at the periodic table. For your transition metals, you would have to write your electron configuration, and your highest energy level would then tell you how many electrons you have in the outermost energy level, and then you can draw your symbol.